Hi there, and welcome to today's solution to physics experiment L4. Now, for experiment L4, what you have here is the measurement of the refractive index of liquid. All right, so you have the aim of this experiment as well as the apparatus, all right, and the method also listed here. Now, for this video, I'll just be providing the answer to the practical manual. All right, so let's get into the question session. All right, so questions here. Question 1 says plot a graph of real depth H versus apparent depth L for the two liquids on the same graph. So on the same graph, we'll be having two different graphs, right? On the same graph sheet. Okay, so let's see our table of values for this. All right, so this is your table of values. Now, most likely, when you do this column here, the column here, N of water and N of kerosene, will not be given, most likely. All right, so you just have to fill them up. And how do you fill them up? Very simple. Note that N is actually called refractive index, and in terms of real depth and apparent depth, N can be expressed as the ratio of real depth to apparent depth. So I'm saying that N, the formula for N is equal to real depth all over apparent depth. All right, so you have this. So hence, if I'm to find the real and apparent depth for each of them, I'll just divide the value of the real depth to the apparent depth for water and kerosene for each case. All right. So let me take an example. So for this side here, to get 1.45, to get this part here, just go to the real depth. Let's take the first row. That's this row here. If I go with this row here, okay. So for this row here, you can see that the real depth here for water is 8.00. That becomes 8 all over. The apparent depth for water, which is this one here, is 5.50. So it becomes 8 divided by 5.5. And that will give you about 1.45 approximately. And that's how we get this value here. This one here. Alright, so that's how we solve this. Also for kerosene, for the first row, come to the real depth for kerosene. That's 7.00. So 7 all over. Come to the apparent depth for kerosene. That's this part here, 5. So if you point 7 over 5, you have approximately, you get actually 1.4. Alright. But then in two decimal places becomes 1.40. That's this value here. Alright. So do the same thing for each of them. That means if I come to the second row, that's this one here, for values, this one here. If I take, let's say I'm taking water. Let me take water here. For water, the real depth of water here is 7.00. So it becomes 7.00 or 7 divided by the apparent depth of water for the second row is 5.00. So divided by 5.00, I'll have about 1.4. But then in two decimal places, I have 1.40. That's this value here. All right, let's take one final one. Still under the second row, under kerosene, right? Under kerosene, if you come here, that's this side exactly. Come here, under kerosene, come down to this. I'm having 6.00. That's this part here. So it becomes 6 or 6.00 divided by the apparent depth for this same row for kerosene is 4.10. So divided by 4.10. In two decimal places, you have approximately 1.46, which gives you this value. All right. So basically, this is how we get the value of each of them. All right. So use this concept to fill out the whole table. That's for your own practical manual. Then when you're done with this, let's head straight to the graph sheet. Now don't forget that you draw the graph for both water and kerosene on the same graph sheet. All right. So if I draw that, what will it look like? All right, so this is what I got when I did my own graph sheet. You have something of this nature. All right, so you can see this. All right, so this is what you have as your graph. So we've successfully plotted water and kerosene. For mine, I use red to indicate water and then blue to indicate kerosene. So this is what the graph would look like. All right, so before any other thing, don't forget that every graph must have your title and scale. So title of this graph is simply the graph of what I have on my vertical axis is h, that's real depth, against or versus, if you want to, you can say versus, h versus, of course, let me indicate units, graph of h in centimeters versus L also in centimeters. So graph of h versus L. So I have this. So this is the title of the graph. Let's get the slope. Let's get the scale used, please. Let's get the scale used. So scale or scale used. I would advise you use the same scale for both of them. So if I look at my scale, I'll say let if I look at the vertical axis, that's the h axis, from here to this point is 1 unit. So I'll say let 1 unit represent represent. So 1 unit from here to here is 1 unit, and you can see that the number here is actually 1. So it becomes 1. The units here is h in cm. So represent 1 cm on the h axis, because I'm plotting h there, which is my real depth. Also, comma, let 1 unit represent what there. So if I look at this here, let's look at the horizontal axis. From here to here represents 1 unit. And if I look at this, the value here, the first value here is about 0.5. So say it represents 0.5. The unit for the horizontal axis is centimeters. So 0.5 cm on the, if I look at this axis here is labeled L. So on the L axis. Alright, so I believe with this you can know how to get your title and your scale. Alright then, so let's go back to our work. Okay. Alright, so if you're done, let's go back to the question. So question 1 has been answered. Let's see question 2. So question 1 answered. Question 2 says, deduce the refractive index of I water, II kerosene from your graph using the relation n equal to h over L. Alright, so how do we do this? Now it's very simple. If I look at what's it called? If I look at the graph again, for the graph, observe that for my graph here, I was plotting h, that's here, you can see h here, that's on the vertical axis, and then L on the horizontal axis. So if they ask you to find the value of n using h over L, that simply means get the slope of this graph. That means I'll get the slope of both water as well as the slope of kerosene, and that's all. So let's see how we can find the slope for water and that of kerosene. Right, number 2. So come down to number 2, which we said is called the refractive index. Let's start with water. So for water, they gave us the relation that n. So let me say n of water. So n of water. So let me use W as water. Okay, let me indicate it here, W. Okay, n of water is equal to, the relation was h over L. So I'll call it h of water all over L of water. And if I'm to do this, my formula will actually be the change in h of water, that's the real depth of water, all over the change in the apparent depth of water. I'll have this. And my formula here becomes h2 for water minus h1 for water, all divided by L2 for water minus L1 for water. So we'll pick out values and see what we have. So let's get H2, H1, L2, and L1 for water using the graph sheets. Now, as I said, that should be the slope of my graph. And if I check here, from me, I'm seeing about a 2.30. I'm seeing a 1.29. So if I check here, I'm seeing 1.295. That's about 1.3 as your answer. But then, let's get this done. So for sake of this class, I'll just have to take off the blue lines. So let me take this one off. All right, so we just have water here, which is this. Now we have to find the slope of this. Remember how we get slope? Um, for slope, we said it's as easy as you see a vertical line this way, a horizontal line this way in your graph sheet. Then when I plotted my graph, right, I had lines like this, something of this nature here. So to get your slope, you pick that point where these three lines intersect. This is the point you'll be using as your point of reference. Okay. All right, let's get back to the graph sheet and see what we can get as point of reference. All right, so back to this. So which point and which points can we pick from here? Now, if you look at this, this is a system graph, of course. It's not as easy as the normal graph, but then let's see if we can pick. Let's say we're picking somewhere here, okay, and then perhaps somewhere. Where should we use? Okay, somewhere here we should do. All right. So I will trace this path downwards. Excuse me. I'll trace this path here downwards. I also trace this path here downwards. I'll trace this path to the left hand side, which is this, and then trace this path here this way. Now this value you have here is your H2. In other words, H2 here is equal to 6. So I'll come back here. My H2 for water is 6. Excuse me. That's 6 minus, let me write this better. That's equal to 6 minus, let's take H1 for water. So if I come back here now, for water, so for water here, you can see that H1 is this value here, which is what? 2. So I'll come back here, H1 is equal to 2. Alright, divided by, let's get L1 and L2. Alright, let's get L1 and L2. So what's L1? So L1 is simply this value here, which is 1. So you can see here. So trace this down. That's your L1. By the way, you should do this anyways. Alright, so L1 here is 1. So I'll come back to this. L1 is 1 minus, let's get L2. L2 is simply trace this part here downwards, which is this point here, which gives you what there? 4. So I'm having this as 4. Alright, so if I punch this, I'm having 6 minus 2, which is 4, all over 4 minus 1, which is 3. So I'm having 4 over 3. If I punch 4 over 3, what I have here is about 1.33. Alright, that means for water, N is equal to 1.33. So this is how I get for water. Let's now get for kerosene. Now, don't forget, kerosene is still under the same graph sheet. So I'll come down here, I'll say for kerosene, II, for kerosene, you have that N, or let's call this K, N of kerosene is equal to H of kerosene all over L of kerosene, which is better written as change in H of kerosene, since I'm taking slope, all over change in L of kerosene. I have this. And this is equal to H2 for kerosene minus H1 for kerosene, all divided by L2 for kerosene minus L1 for kerosene. All right, let's take values and see how we can fix this in. All right, so this one we have for what's it called, for water. I'll take this one off. Now, usually this and the kerosene should still work on the same graph sheet, but then just to ensure neatness, I'll clean this off. But for your graph, please do not clean it. All right, just trace it and then leave it. All right, so what I'll do here is simple. I'll just I'll just come here. I'll deactivate the one of water and use the one of kerosene. Alright, so for kerosene, I have this. This is my kerosene graph. Again, I'll still pick out those points again. So look for where the lines intersect. The lines intersected at this first point here. So this is the first point I'm taking here. This one here. Okay, where can they intersect? There's no perfect intersection, but let's just see if we can use this one here. Right, let's see if we can use this one here. But it's not a perfect intersection. Alright, but for yours, please take perfect intersections, please. Alright. Okay, so let me use here. Okay. So if I trace this one here, of course, don't forget you also have to do this. Trace this one like this to the right this way, then like this. Form your kind of triangle to create your slope. Okay, then trace this man to the right like this, or to the left this way. Trace this way too. Okay, trace this one down. Trace this down. All right. If I choose one to the left here, what I have here is 7. So for kerosene, H2 is 7. So I'm having H2 as 7 minus, for kerosene, H1 is this one here, which is this one here, which is 2. So I have 7 minus, this becomes 2, all divided by L2. So L2 is simply trace this man down here. I'm having this one here, which is 5. So it becomes L2 is 5 minus L1. L1 is trace this downwards here. This one here. L1 is 1. So I have L1 as being 1. Alright, so proceeding. This is equal to 5 minus 7 minus 2 is 5, all over 5 minus 1 is 4. So I have 5 over 4. If I punch 5 over 4, I have about 1.25 as my answer. Alright, so it means for this one here, your answer is about 1.25. Alright, but please make sure your values are very correct. Okay, you might not really have the same thing as me, but please do not change your answer. Right, it doesn't mean this one is actually very correct or no, but this 1.33 is actually very correct, this one here, because that's actually the refractive index of water, 1.33 actually. So even if you get I think the error should be about 1.30. If you have about 1.30 to about 1.35, you are okay for this part here. It's okay, it's acceptable. Okay, all right, let's proceed. All right, so same thing here, right? 1.25. If you have about 1.3, it's okay. If you have about 1.4, it's okay. All right, so that's it basically. All right, let's proceed with this. So having got this, let's go back to 1.33 and 1.25. Okay, let's go back to this. So I for water, we have that N is equal to 1.33. I for, okay, for kerosene, you have that N is equal to 1.25 in two decimal places. So you have this. All right, question 2 is answered. Let's go to question 3. Question 3 says, what is the depth of a swimming pool which appears to be 10 meters deep when viewed directly from above its surface? Take N for water as 4.3. All right. So they said the depth appears to be 10 meters. So 10 meters is actually your apparent depth. So when they now ask you what is the depth, they ask you for the real depth. In essence, what is the real depth when we are given that the apparent depth is 10 meters and they give you the refractive index of water as 4.3. So how do we do that? Very simple. We said N is equal to real depth H all over apparent depth L. Okay. If I solve this further, it's as simple as this. N, excuse me. If I solve this further, it's as simple as this. So N is about 4 over 3. So 4 over 3, that's N. It's equal to H, real depth unknown, all over apparent depth. Say 10 meters. So it becomes 10. Now from this, you know that my next task will just be to cross multiply. All right, so 3 times h, that's 3h, is equal to 4 times 10, that gives you 40. To get h, I'll divide here by 3, divide here by 3. Okay, and if I do that, you have that h, if I do that, you have that h is equal to 40 over 3. So if I punch 40 over 3, what I have there is about 13.33. It's about 13.33. Of course, they said in meters, so in meters. So my answer here is 13.33 meters. Okay, last question there, question 4 says, differentiate between reflection and refraction of light. All right, let's differentiate between reflection and refraction of light. All right, so solution, question 4. Your answer is this: number 1, that reflection is the change in the direction of light at the interface between two different media, so that the light returns to the medium from which it originated, while refraction of light is the bending of light rays as it crosses the boundary between two media of different densities, all right, thereby causing a change in its direction. Okay, all right, so that's one of the differences. This a second difference is that for reflection, the angle of incidence is the same as the angle of reflection, right? So for reflection, angle of incidence equals the angle of reflection, while for refraction, the angle of incidence is not equal to the angle of refraction. So these are like two differences between reflection and refraction. So I hope you found this useful. Please, if you enjoyed this video, don't forget to like. Please always hit the like button, okay? It helps us to grow. Don't forget to leave a comment. Tell us if you enjoyed the video and also suggest other experiments you want us to do. If it's your first time here, kindly subscribe to this channel for more content. And please don't forget to share this content to your friends so that they can also learn. You can also visit my website for my books and courses, www.jonahemmanuel.com/books or courses, so you can check out the available books and courses. Thank you and see you in the next class.